So a capacitor is made of two large metal discs with a radius r separated by a distance of s, where r is much greater than s. Each disc has a thickness of t. The left disc has a charge of positive q and the right disc has a charge of negative q. Calculate the change in potential between the points 1 and 2. So here's our negatively charged plate and our positively charged plate, and I didn't add it in the question, but the thickness, T, is going to be much smaller than the radius, so we don't really have to worry about it. So first things first, find the electric field very close to a thin disk. Well, there's a long integration for that, but you'll end up with E is equal to Q over A over 2 epsilon naught. Well, since we have two disks that are also very close together, we're just multiplying this by 2 and then these values cancel. So then we find the electric field between the two disks that are close together, and we do that by just substituting A for pi r squared, and that's going to be the equation that we use to find our electric field. Now, we're going to do here is the change in potential the change in potential is equal to negative integral from the initial point to the final point, E dot dl. So delta V is equal to negative E dot dx times cosine of 180, which is negative 1, so it just cancels this negative sign. We get E delta x, or dx. It doesn't really matter. So delta V is equal to Q over epsilon naught pi r squared times S over 2, because this is delta x here. It's the change in our distance, because we're only finding the distance halfway it's going to be from one plate to the halfway point. So it's going to be S over 2. So at this point, the problem's done to create the equation for it. But if we want to actually calculate the change in potential, we can do it by just plugging in numbers. So I have a few examples here. So we're going to have S be 4 millimeters, our radius is going to be 2.5 meters, and our charge on the plates are going to be 4 times 10 to the negative 8th coulombs. I just picked these numbers at random. They work pretty well. So the change in potential is going to be 4 times 10 to the negative 8th coulombs over epsilon naught, which is a constant, 8.85 times 10 to the negative 12 newtons times meter squared over coulomb squared, times pi times 2.5 meters squared, times 0.0004 meters over 2. This is just converting this 4 millimeters into meters, and this total is 0.046 volts. So that's the total voltage or change in potential for this capacitor.